Entering the 21st century, the new military revolution has begun, and the development of informationized warfare equipment has been accelerated. Countries around the world have increased their investment in advanced aviation equipment. The old equipment represented by the French-made Phantom series of fighters in the Pakistan Air Force faces a situation of far lag behind the rest of the world in terms of air combat ability and performance, and it is urgent for need to be updated. Although the Xiaolong JF-17 Thunder has begun to enter the ranks of Pakistan Air Force on a large scale, due to the positioning of the JF-17 Thunder as a light fighter, it has certain limitations, especially in terms of range limit and ground attack capability. Therefore, purchasing a medium-sized advanced fighter with stronger performance and multi-purpose capability has become an urgent need of the Pakistan Air Force. In 2019, China exhibited a model of the J-10C fighter jet for the first time at the Dubai Air Show. On June 25, 2021, China and Pakistan signed an agreement to officially export to Pakistan the J-10CE Raptor fighter jet. This will be the latest fighter jet equipped by Pakistan. It is the most advanced product exported by China's aviation industry so far. Less than a year later, the first batch of 6 J-10CE arrived in Pakistan on March 4 of this year. On the 11th of the last month, the Pakistan Air Force in Kamla Air Force Base held the first batch of 6 J-10CE fighter handover ceremony. Pakistani Prime Minister Imran Khan attended the ceremony and entered the cockpit. The J-10CE fighter jet is an all-weather single-engine, multi-purpose third-generation advanced fighter jet independently developed by China. Domestic fighters have a tradition of being named after beasts. The J-10 series has a nickname, Raptors. As the latest model of the J-10 series, the J-10CE inherits the characteristic canard layout with excellent maneuverability of the J-10 family. Compared with the basic model, J-10CE has completely replaced the latest avionics system, which is similarly used on the J-20, and equipped with advanced active phased array radar, infrared photoelectric detection device and electronic warfare system. It has strong external weapon capability, excellent system coordination of a combat operation, with advanced super field of view for multi-target attacks with multi-mode precision strike capabilities in a strong electronic countermeasure environment. At the same time, it has excellent low and medium altitude maneuvering combat, supersonic flight, short takeoff and landing, large combat radius, long range, and the ability to refuel in the air. It is capable of so-called 3 first find the targets, first lock them, and first strike the enemy in the air before the enemy acts, which is main goal for the J-10CE in the battle. The handover ceremony of the J-10CE at Kamla Air Force Base marked the official introduction of another new type of Chinese aviation main battle equipment after the ZDK-03 airborne early warning aircraft for the Pakistan Air Force.
The two experts who came to the studio today, I would like to introduce Mr. Song Xinji and Mr. Wei Dongxing. Welcome to both of you. On March 23, 2022, during the National Day military parade in Pakistan, a fighter jet from China appeared at the parade site. It is the J-10CE imported from our country. The appearance of the J-10CE has attracted great attention from military fans and netizens at home and abroad. This marks China's main combat equipment that has been officially served in the Pakistan Air Force, and began the export of China's new generation of aviation main combat equipment along with support system, parts and services. Today, in this program, we will give you a comprehensive view of Pakistan's introduction of a Chinese J-10C export model. Let's start with the aerodynamic shape, the most decisive element for an aircraft. Let's watch a short clip first.
The J-10 series fighter jets use a single engine, single vertical tail, full motion canard, and delta wing aerodynamic layout, with a pair of pelvic fins under the rear fuselage. The transition between the main wing and the fuselage has a distinct wing body fusion. Among the fighter jets successfully developed in China, the J-10 series is the first fighter jet with a full motion canard layout. Compared with a delta wing fighter with a rear-mounted horizontal tail such as the MiG-21, the J-10 in the canard layout is more stable during transonic maneuvers. Compared with tailless delta wing fighters such as the Phantom 2000 etc., the canards of the J-10 can generate much higher even lift, thus achieving good low altitude and low speed performance. An early model of the J-10 family, the J-10A, featured a rectangular adjustable belly air intake. The air intake can be adjusted automatically with the change of its flight speed, and the thrust loss is small. It is significantly better than the fixed, non-adjustable intake of US F-16A, FA-18C and other models. The aerodynamic shape of the J-10B has been improved. The nose is lengthened and bold. The section of the nose was changed to an oval shape, the nose speed tube was removed, and a clam-type air intake was used. The official name of the clam intake is DSI intake. A bulge above the air inlet is used to replace the boundary layer partition and gap, which not only greatly reduces the structural weight, but also reduces the radar reflection cross-sectional area and improves the air intake efficiency. It also eliminates the chattering problem experienced with the J-10A in the past. At the 2018 China Airshow, the J-10B performed the Cobra maneuver. The 9-ton fighter actually hovered in the air for a few seconds, fully demonstrating the J-10B's excellent high angle of attack aerodynamic performance. The aerodynamic shape of J-10C is basically the same as that of J-10B. Only a few details differ.
The short video just now introduces us to the features of the aerodynamic layout of the J-10 family and some changes that have been made during the improvement process. However, the video also mentions that the J-10B and J-10C are only slightly different in appearance. How can we distinguish between J-10B and J-10C from their appearance?
Objectively speaking, if it is 100 or 200 meters away, it is very difficult to tell the difference. But looking at some details up close, one can still see some small difference. For example, one may notice differences in details of the position and number of antennas, including the specific installation positions of some warning devices, etc.
In addition, when we talk about the aerodynamic layout, we know that the J-10's most obvious feature is the canard layout. As we all know, there are many fighter jets in the world with canard layout. For example, the French Rafale, serviced in the Indian Army, and the Russian-made Su-30 MKI also have canard designs. What is the difference between the aerodynamic design of the J-10C and these fighter jets that also use the canard layout?
First of all, for the European Rafale generation, many of their fighter jets used a canard wing layout, and they are known as the Three Musketeers in Europe. Rafale, Typhoon, and Sweden's Gripen, they are all canard style. But there is an important indicator when we look at the design of this type of aircraft. It is the ratio of the front wing area to the main wing area. Simply put, we look at the size of the canard wing. If the proportion is larger, it means that the airflow of the canard wing will affect the proliferation of the main wing more. Among these fighter jets used a canard wing layout, the canard wing of the J-10 accounts for the largest proportion. The problem with a large front wing is that it is good when the vortex lift is high and bounded, but once the vortex floats up and out, when it leaves the main wing area, the vortex lift will suddenly decrease. This is scary. As we all know, such a fighter jet has to be controlled by a computer. The control software plays a key role in this regard. Dare to use such a large canard wing. First, we have to have a high confidence that we can control the vortex. Our software design engineers developed the handling system adapts to a full motion of canard wing extremely well. Even at a high angle of attack and large sideslip, we were still able to control the aircraft. Second, if you pay attention to detail, you will notice an important concern of European jets with canard wing is that when taking off and landing, if the canards are used to act, the fighter cannot balance the bowing moment of the jet due to the small front wings. That is to say, if the front wing is used, the head stage will generally not easily rise. But the J-10 can move the front wing when taking off and landing. Of all the canard design jets, the J-10 performs best in terms of takeoff and landing, which implies that the control system and software of J-10 is excellent.
Let's watch a short clip of a J-10 documentary, in which several interviews with original J-10 designers were conducted.
The key to achieving high maneuverability for the third-generation aircraft mainly depends on optimizing aerodynamic layout. At that time, there were mainly two design schemes for the third generations of fighter in the world. Duck style and side strip have their own advantages and disadvantages. Both have the third generation advantage. For example, in the United States, they made with side strips. What we do is duck style. Their common feature is that the vortex of the airflow rolled out from the side strip or duck wings is a stable and strong vortex. When the airflow passes through the top of duck wings, it creates this kind of vortex in front. The vortex came close to the wing surface, and there was also a vortex on the leading edge of the main wing. When the two vortices are well coupled, the combined vortex is very strong. It's like a tornado. More lift is produced. We no longer use the mechanical controls of the past, but instead are controlled by computers. This is called fly-by-wire flight control. In the past, the rudder and wing surfaces of our aircraft were controlled by the pilot's control stick and pedals. They are mechanically connected to drive. In the past, for the fly-by-wire operation, this is unnecessary, as its displacement covets an electrical signal which is transmitted through the cable. The fly-by-wire control brought a revolutionary change for the control of the aircraft. The deflection of the rudder surface that changes the action of the aircraft is no longer directly controlled by the pilot. It is achieved through complex calculations of compute. Simply put, the fly-by-wire flight control system must analyze and sort all possible flight conditions in advance, and give a solution. The computer makes the judgment and emergency handling in complex situations. All shall be done by computer. However, the flight attitude of fighter jets in the air is very complicated, and there are countless situations that may be encountered. To ensure the safety of the aircraft, all circumstances must be considered as much as possible. In fact, the problem we focused is malfunction. What should I do if there is a problem with the signal? As long as you can think of it, and as long as you think it is possible, you have to consider and deal with it. In other words, all routes must be set in advance, according to design requirements. Only failures with the probability of 10⁻⁷ power occurring within 1 hour of flight can be ignored. Availability must be 7 nines. That is 99.99999%. As long as you can think of everything else may happen, you must design an emergency plan for and store in the computer. This is an extremely complicated and arduous task. Ask people to be meticulous and patient to work on. After the design is completed, in order to eliminate possible safety hazards, test pilots are required to evaluate and experience on the simulator. At least 2 pilots fly the same subjects we studied. As long as one pilot has a different opinion, the third pilot will fly again. If the third or fourth pilot still has the different opinion, we must also fully analyze that pilot's opinion. Our designers are just great. They will immediately change and implement according to analysis results from the comment or opinion of the pilot. They don't miss any suspicious points. During the development of the J-10, serious accidents involving fly-by-wire fighter aircraft from abroad continued to spread. Even the plane crashed and pilot died. This made the J-10 flight control system design team more nervous. They are all working overtime. The avionics system is known as the nervous system of the aircraft, through which pilot controls the aircraft to perform various combat tasks. The avionics system of the second-generation aircraft is relatively simple. Each device forms its own system, but the mission of the third-generation aircraft is very complicated, and the previous legacy technology is completely inapplicable. It has to hang dozens of weapons against air, ground, long-range, short-range, and aim at various moving and non-moving targets. The second-generation aircraft is not convenient, not possible. We need to build a network system. Start with the preparation of a brand new computer language. The avionics system designers moved forward little by little, from navigation to communication to the operation of dozens of weapons must be programmed into software. It took more than 10 years to complete the full upgrade of avionics. Every document is hundreds or thousands of pages. This workload is very large and very stressful. We work overtime every day.
After the analysis by the two and watching the short clips just now, we have a preliminary understanding of the aerodynamic shape of the J-10, and saw the Chinese designer's wisdom. Especially for the control system, we learn how the computer software plays a key role in J-10 design, which makes such an aerodynamic layout of the J-10 perform the best. But for a fighter, in fact, its missile load, range, and its engine are also the critical elements. Before we take a look at these aspects, first let's watch a short clip for the engine of J-10C.
The J-10CE exported to Pakistan uses the Chinese-made WS-10B Taihong engine, not the Russian-made AL-31F engine used in earlier J-10C models. Aero engine is the heart of the aircraft because it's extremely difficult to develop, and is also known as the jewel in the crown of modern industry. The successful development and maturity of the Taihong engine mark that China has achieved a historic leap on the road of independently developing jet engines. At the China Air Show, the J-10B with a Taihong vector thrusting WS-10 engine in a demonstration performed difficult maneuvers such as J-turn and fallen leaves etc. abatic air action.
The short video just now introduced us to the export model of the J-10C, which was exported to Pakistan this time. It uses the Taihong engine. In the eyes of the two experts, what are the important significance of replacing with the domestic engine for the J-10?
The Taihong serial engine has been used on various fighter jets of the PLA Air Force, showing that China's aviation industry, especially the aviation engine industry, has made a turnaround in progress under the Taihong brand. I can use 3 leaps and 1 breakthrough to describe this turnaround. 3 leaps are: first, we all developed turbojet engines in the past, and now we have developed turbofan engines, which have a far longer cruise range and less fuel consumption. Secondly, in the past, we all developed medium thrust engines, and now the turbofan engine WS-10 is a high thrust engine. The third leap is in the thrust to weight ratio of the engine, because it is the most important indicator of engine performance. The generations of fighter jets are also determined by the thrust to weight ratio of an engine. Fighters with medium thrust engines belong to the second generation of fighters. The Taihong WS-10 engine belongs to the third generation fighter. What a breakthrough I mentioned here is that in the process of engine research and development, we have some major breakthroughs in high-performance related technologies. This series of breakthroughs shows that we are able to develop more advanced engines. From then on, we have expertise, experience, resources, and good technical reserves.
In addition, in the short video also it was mentioned that J-10B test fighter was equipped with a vector thrusting technology. At that air show a few years ago, the pilot made some difficult maneuvers, many so-called anti-Newton's law, and the scene was very shock. We should have witnessed it with our own eyes. So how do these difficult maneuvers help in the actual combat in the air?
I think vector thrusting engines still have tactical value. It can make the fighter more flexible in the process of air combat. For example, it can perform better tail biting in close-range aerial combat. This means that it can easily take an advantage fire launch position, and it has a smaller turning radius. Therefore, the innovation of this engine technology, especially the use of vector control technology, can actually allow pilots to better control their own combat platform during the process of close-range air combat.
Now that we've learned the engine on J-10CE, let's take a look at 2 systems that are critical to air combat: airborne weapons and sensory detection equipment. Let's watch a couple of short videos first.
In modern air combat, seeing far and accurately is still not enough. China's development on domestic fighter on-board radar continues to move forward with capability of detecting more multi-target. New phased array radar capability is many times of traditional mechanical scan radar, and with greater ability of autonomous capture of targets, good anti-jamming performance and strong ability to detect invisible targets. Most important is the new fighter radar system can detect multiple targets simultaneously and lock them accurately. China bid farewell to the era of only locking up single target. Since then the J fighter's survivability and combat effectiveness have greatly increased. J-10 is China domestically made very first third-generation fighter. It is equipped with a highly digital and integrated fire control system and a series of advanced electronic equipment to see farther and more accurately. It can mount multiple advanced missiles, coupled with good maneuverability, so that the combat mission of the J-10 can be multi-role switched between pure air combat for air dominance and attack ground. Starting from J-10B, the domestic fire control system reached high-end level. There are various means to attack the targets even under severe electromagnetic interference conditions. At the same time, the number of tracking targets and locked up to attack has been greatly increased, thus the air combat performance is considerably better. With the development of modern warfare toward informatization, electronic warfare capabilities have become the military strength that China has built with all its efforts. The J-10B is equipped with a powerful electronic warfare system that can perform air defense suppression tasks very well. In 2018, J-10C began to be equipped with more advanced avionics systems and multiple advanced weapons on combat duty, and adopted a new system of fire control radar. Its various performance indicators are better than those of world top single-engine fighters.
A big difference between the J-10B and the J-10A is the nose radome. The cross-section of the black radome of the J-10A is circular and the dividing line of the fuselage is perpendicular to the ground. The light gray radome of the J-10B is elliptical in section and the dividing line of the fuselage is also inclined. This shows that the airborne radar of the J-10B has been upgraded from the pulse Doppler radar to a phased array radar. The antenna array of phased array radar is usually installed at a certain elevation angle. The radar of the J-10C has been further upgraded with the latest active phased array radar, which is used on J-20 as well. With a powerful radar, the J-10C can better exert the power of the PL-15 long-range air-to-air missile, and PL-10 short-range air-to-air missile. At the same time, it can also mount electronic warfare pods, and YJ-91 anti-radiation missiles to carry out electronic suppression and precision strikes on enemy ground radars. In addition, the J-10 series fighters can also mount air-to-surface missiles such as the improved KD-88, exhibiting their multi-purpose capabilities.
The short clips just now introduced several upgrades of the J-10 family in terms of airborne radar and the various missiles that the J-10CE can use. It also specifically mentioned the PL-15 long-range air-to-air missile. In the eyes of the Indian media, this PL-15 is very powerful. They compared the PL-15 to the Meteor air-to-air missile used by the Rafale. Next, I would like to ask Mr. Song to shed light on the differences between these two air-to-air missiles.
Firstly, the biggest feature of the Meteor missile is the use of a ramjet engine. We can see that it has two large air intakes. The biggest advantage of the ramjet is that it can work for a long time. Its downside is that it needs enough airflow intake to work. Because of those two large air intakes, caused to a lot of resistance. It needs to accelerate in the first 30 kilometers. After reaching a certain speed, then the engine can run at high speed. In the initial 30 kilometers, it basically loses its attack ability. Secondly, inertial guidance is impossible due to the enormous drag caused by those two large air intakes. So, once the engine runs out of fuel or engine shut off, it will dramatically de-accelerate, and then lose its ability to attack. Therefore, it has two attack blind ranges, about 30 kilometers of initial range, and a far-end terminal range. However, our PL-15 missile uses a dual-pulse rocket engine. The missile features an active electronically scanned array radar seeker, and has an alleged range exceeding 200 kilometers. The pulsed rocket motor is made by pouring each segment of propellant separately. The benefit of the pulse rocket motor is that by the command ignition of the subsequent pulses, near optimal energy management of the propellant burn can be accomplished. There are two separated fuel reservoirs. In this case, it is equivalent to two pulsed rocket motors, and of course, no need of air intake. The engine can run at full speed immediately after launch, and the missile speed can reach Mach 3 or more immediately. It can cruise without fuel in the medium range under inertial guidance. Entering the long-range segment, it fires the pulse rocket motor a second time, and the missile speed can again exceed Mach 3. Therefore, the PL-15 missile can effectively attack the enemy plane at supersonic speed in the whole range.
In addition to radar and missiles, optical and infrared detection and tracking devices and electronic warfare systems have an increasingly important role in air combat in the stealth era. So what is the strength of J-10CE in this regard?
For the infrared detection device on J-10C, the media has noticed some details. It may be a device that can be turned. Therefore, it has a wider field of view. Export version of J-10C is equipped with such a system to improve the reconnaissance capability of the fighter, including the detection and identification capability of the target. Americans are now behind us in this regard. Because, like the F-16 and F-15, there is no such equipment on board. This system was later found to be very useful, especially in the course of anti-stealth fighter operations. They're putting a pod under the plane right now to add this capability. If that's the case, it seems a bit of a superfluous. First, the fighter is heavier, and secondly, a precious pod for weapons is sacrificed. Thereby one less missile or bomb pod. But we have such an onboard system, which shows a more comprehensive consideration in the overall design.
Thank you for your detailed explanation. It is known that J-10C has improved in terms of stealth. There are many updates for stealth features on J-10C. Let's watch a short video to learn how J-10C improved its stealth features.
What I have in hand is a sample of a stealth material. It's like rubber plywood, with many layers. The layers inside look like this. There are many circles like small copper coins on it, and the pattern on the back is also very beautiful and regular. These are specially designed micrometal structures, which can deflect and scatter or absorb radar waves effectively. The sample on the left is very light, and the sponge-like material inside is also a radar-absorbing material. And this rubber-like stealth material is very soft and can be attached to the surface of the equipment like a veneer. The most common is this kind of so-called stealth-absorbing paint. It can be evenly brushed on the surface of plane-like paint. On the back of this material is actually an ordinary exposed steel plate. Now I will bring the sample to the laboratory so we see the difference between two sides, one with stealth paint and other side without. He aimed the radar at the sample. The sample gradually rotates 360 degrees. He measures the intensity of the radar beam reflected off the sample. Of course, different angles have different reflection rates of radar. This is the test result. In the graph, the abscissa is the rotation angle. We can see that the curve in this section is very undulating and sharp, which means that the exposed steel plate has a strong reflection of electromagnetic waves. The relatively stable curve here represents the reflectivity of the painted side. In contrast, it is shown that the stealth coating has less reflection of radar waves, and it absorbs a lot of electromagnetic wave energy. Like the J-20's canopy as well as the US F-22 Raptor canopy, the J-10C also offers an option for canopies coated with a thin layer of indium tin oxide, which gives it a golden tint, in order to reduce the radar cross-section of the aircraft. It actually comprises two sheets of polycarbonate, sandwiched between two layers of optical glass, fusion bonded in an autoclave and drape formed over a canopy blank, which effectively diffuse or absorb radio waves.
Today we have conducted a comprehensive analysis of the J-10CE. In fact, for the Pakistan Air Force, J-10CE should be said to have introduced fresh blood for them. We will wait and see how the J-10CE performs in Pakistan in the future. Thank you very much for coming, and thank you for watching. See you on the next show.